Given galactic relationships and immutable cosmic laws, it appears as though every process occurring in the universe is painstakingly coordinated with every other one. Of course, we know that our planet is a component of a superordinate planetary system whose representatives all revolve around a common host star. The question of what would happen if we removed a planet from the solar system is an intriguing one. Would the loss of one of our galactic neighbors have a significant impact on the other celestial bodies, or would the disappearance of a planet have no notable effects in the vast context of the universe? We would want to examine this intriguing issue in greater detail with you. If you're excited about today's amazing occurrences and groundbreaking space discoveries, don't forget to click the bell and subscribe to our channel so that you can follow us on our future exploration of the universe's greatest mysteries. By giving us a thumbs up, you let us know that you find our videos interesting. The solar system. In addition to the natural satellites, the dwarf planets, and other smaller bodies like comets and asteroids, as well as the entirety of all dust and gas particles, our domestic solar system consists of 8 official planets, starting from the central host star. These are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. All of these structures are gravitationally connected to the Sun, and the massive center star alone is responsible for more than 99% of our galaxy system's mass. While the terrestrial planets Mercury, Venus, Earth, and Mars are distinguished by their solid composition, the various celestial bodies in the solar system are as fascinating as they are unique. The chemical makeup of Jupiter, Saturn, Uranus, and Neptune, the outer gas planets, is entirely different. Light gases like hydrogen and helium make up the majority of the gaseous celestial bodies. Every planet has a unique orbit around the Sun, and the most varied orbital periods arise from the characteristics of each individual rotation orbit and the current distance between the celestial body and the Sun. For example, our Earth takes 365 days to complete one full orbit around the Sun, whereas Neptune takes 165 years, with an orbital period of only 88 days. Mercury is the fastest planet in the solar system. Despite all scientific research, there is currently no widely accepted definition of the exact size of the solar system. Previously, the heliosphere was thought to be the edge of the solar system, but after the discovery of distant trans-Neptunian objects, scientists realized that there are still countless entities gravitationally bound to our central host star gravity beyond the heliopause. Before asking what would happen if a planet vanished from the solar system, it is advisable to first examine the effects of gravity. As most of you are undoubtedly already aware, this fundamental physical force manifests itself in the mutual attraction of masses. In theory, the gravitational force decreases with increasing mass distance, but it has an infinite range. This also means that, unlike magnetic or electrical forces, gravitation cannot be shielded in our terrestrial context. It is evident in the way that all objects appear to fall downward, or, to put it another way, in the direction of the center of the Earth within the solar system. This mass attraction determines the orbits of all planets, moons, and other celestial bodies throughout the entire cosmos. The principle that applies is that the more mass an object has, the greater the gravitational force it exerts. As previously mentioned, the Sun is by far the most massive object in our immediate galactic neighborhood, and the central star is the driving gravitational force in the solar system. The individual planets influence one another with regard to their mass attraction, even if these effects cannot be compared with the force of the Sun. Even so, it is still unclear what effects a celestial body's appearance would have on the other planetary system representatives. If a planet vanished, the effects would depend on the planet's removal from the star map, which would indicate the corresponding consequences. In contrast, we should examine each planet separately. As a result, our mental game starts with the planet that is closest to the Sun and the smallest planet in the solar system, Mercury. Because of the average distance of just over 30 million miles between the celestial body and the host star, Mercury has very little effect on its more distant galactic neighbors. In fact, experts agree that the planet's disappearance would not significantly alter the order of the solar system. Because of its small diameter of only about 3,000 miles and its close proximity to the Sun, which means Mercury has a minimal impact on interactions within the planetary system. Venus, the situation would be quite similar in the case of Venus, if the second and third smallest planet of our solar system, which is often called Earth's twin, would disappear. This would have no drastic consequences on the cosmological total context. For life on our Earth, however, a noticeable change would occur in one aspect. The celestial body named after the Roman goddess of love is the second brightest object in the night sky after the moon. So if Venus were to disappear, we would also lose our fascinating morning star Earth, as is well known. Our blue home planet is the only celestial body on which we have so far been able to prove the existence of living beings. What would happen if our terrestrial homeland were erased suddenly from the star map? Well, the consequences of this scenario are actually obvious. In this case, no one would be able to watch this video with the disappearance of our species. Our thought experiment would have become meaningless in itself, Mars, while the loss of Mercury and Venus would have no significant consequences for interactions in the solar system. The disappearance of the red planet would have noticeable effects. The disappearance of the fabled celestial body could be said to benefit our terrestrial security. For indeed, the threat from near-Earth asteroids would diminish considerably. In this case specifically, the so-called asteroid belt is located between Mars and Jupiter. As the name of this structure reveals, it is a clustered accumulation of asteroids. So far, over 650,000 of these astronomical small bodies have been located there. The individual formations are bundled thereby mainly by the gravitational force of Jupiter. However, it happens that some asteroids are hurled out of their original orbit by the force of the Sun. In this case, the gravitational force of Mars acts again like a kind of galactic slingshot, which accelerates the bodies in the direction of our blue home planet, if Mars were to disappear now. It would affect this cosmic acceleration process, so that the risk of the Earth being hit by an asteroid would be considerably smaller. Jupiter, with an impressive equatorial diameter of almost 89,000 miles. In contrast to the other celestial bodies that have been shown thus far, Jupiter becomes the largest planet in the solar system. Because of its enormous size, Jupiter is a gas giant rather than a terrestrial planet. As previously mentioned, Jupiter's massive gravitational pull is also responsible for keeping the entities in the asteroid belt in steady orbits. In this way, the gas giant also acts as a terrestrial protector, protecting our home planet from numerous asteroid impacts over the course of millions of years. Jupiter's gravitational field is so strong that it can deflect those astronomical bodies heading towards Earth and throw them out of the solar system. However, Jupiter's disappearance would not alter the fundamental order in the solar system. In addition to its significant intrinsic diameter of around 75,000 miles and its at least 82 natural satellites, Saturn ranks second among the biggest planets in the solar system. Above all, the planet named after the Roman god of wealth is so fascinating because of its complex ring system. It is unlikely that the disappearance of Saturn would have any significant impact on the planets in the inner ring, but the situation is different for its direct galactic neighbors. Because of its size and mass, Saturn influences the orbits of Jupiter and Uranus. Uranus's diameter, at over 30,000 miles, is roughly 4 times larger than Earth's. But this ice giant is simply too far away from the inner planets for its disappearance to have any significant impact on our terrestrial life. This is not true for the outer reaches of the solar system, but it would have noticeable effects on the Kuiper belt. Neptune is the 8th and outermost planet in our solar system. It is located on average 3 billion miles from our home planet. Beyond the ice giant is the ring-shaped, relatively flat region known as the Kuiper belt, which is home to over 70,000 objects with diameters greater than 65 miles, including Pluto. With its gravitational pull, Neptune greatly influences the motions of these objects. If the planet disappeared, there would be unholy chaos and many collisions within this galactic area, but the changes for Earth would be minimal. Let us know what you think of our video today. We look forward to hearing from you.